Item 2, how do we calculate slope? Number 3, why does a line that is a straight line, whether it's flat, or tilted up or down, why does a line mean speed is constant? And you know constant means unchanging. Number 4, why is average speed average? What about it is average? And then last, what goes in the box in long division? Okay, so there are our 5 elements. Zoom in on them. Okay. Let's get started on the first one. What are the elements of a proper graph? And as you can probably tell, my son is here, and he's probably going to correct me when I forget something. Okay? So, that's Leland. So, let's make a graph. Okay. Let's pretend we are driving along in our car. Okay? Driving along in the car, and we are trying to get from Whiting to our grandfather's house in
East Chicago,
New York.
Okay.
In Kinderhook, New York. Okay? So, we're going to graph our motion on that drive. Okay? The first thing we need is a title. And so we're going to make our title driving to Kinderhook from Whiting. Element 1, a title. Element 2, we need our X and Y axes. And because this is a basic motion graph, our X and Y axes are going to have distance on the Y axis, that's the up and down axis, distance, and time on the x-axis. We have to have units. We'll pretend we are not in science class, and we will make our units for distance miles and our units for time hours. Notice, please, that we show miles with MI, okay? And we show hours just with an H, okay? So, we're going about 800 miles. So, let's make this 100, 200, 300, 400, 500, 600, 700, and 800. And then our time is going to go like this. It's going to go, we start at 0, of course. It's going to go 1 hour for 2 squares, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so there we are, 800 miles, and we have from 0 to 15 along here. All right, so here's our situation. In the first hour, let's say we went, so 1 hour, we went 50 miles. That's our first hour. 1 hour, 50 miles, that's halfway to 100. In our second hour, we made it another 50 miles, so now we're at 2 hours and 100 miles. In our third hour, we went another 50 miles, and in our fourth hour, we went another 50 miles. So there we are, hour 1, 50 miles, hour 2, another 50 miles to get to 100, hour 3, another 50 miles to get to 150, and hour 4, another 50 miles to get to 200. Let's go ahead and connect those particular data points with a line. Now what happened was we got tired and we decided to take a break, and for the next 2 hours we stayed somewhere in Ohio, and we had a really excellent meal. So at hour 4 we stopped where we had been at 200, and we didn't go any further distance in hour 5 or hour 6. Then we decided we were running out of time, so we decided that we needed to speed. Oops, not good. So from hour 6 to hour 7, remember we're 200 miles along, so from hour 6 to hour 7, we went 75 miles. So we go up from 200 to 275. And in hour 8, we go another 75 miles, so we go from 275 to 350. And in hour 9, we're still going 75, so we're going from 350 up to 425. And in hour 10, we do another 75 from 425 to 500. Okay, so you see that? Each hour, we go up 75 miles further from where we started. Let's connect those dots with a blue line. Now let's back up and see, now that we've done this, what are all the elements on our graph? Because that's the first question we're answering. We have a title. We have axes with a scale. Okay, and your scale has to make sense given the data that you're going to have. So I'm going about 800 miles, so I know I need to have at least 800 miles worth of distance. And I just know from experience it's going to take about 15 hours, so, well, it usually does. We had a really long stop here. So I gave myself about 15 hours, okay? Each axis, the vertical axis, and the horizontal axis, vertical's up and down, horizontal's back and forth, side to side. Each axis has a label and units. And on a basic graph of motion, the y-axis, the vertical axis, the up and down one, takes distance. And here we have miles. And the x-axis takes time. And here we have hours. Okay? So that is our first question answered. What are all the things on your graph? Good. Let's look at question 2. How do we calculate slope? Okay, so you all remember slope right? Slope is all about how steep your line is. And the formula for that is we say that is rise divided by run. So it's how much up you get for each amount of across, how much rise you get for each amount of run, how much y you get for each amount of x, and here that's how much distance you get every hour. Okay? You can calculate slope. You can calculate slope using any 2 points on a straight line. So we can use any of these points. This point where we started at 0, 0 in Whiting at hour 0. This point, this point, this point, or this point to calculate the slope of this straight line. We can use any 2 of these 3 points to calculate the slope of this bit of line. And we can use any 1, 2, 3, 4, or 5 of these points to calculate the slope of this part of this bit of straight line. We'll talk about using, say, a point here and a point here to calculate the slope of a line later. But right now, we want to think about having 3 different straight lines, those 3 segments. So just for the fun of it, let's look at our first line, our black line, and let's use our first point and our last point. Okay? Our first point is the point 0, 0. It's 0 hours, 0 distance. And our last point is point 4, 200. 4 hours, 200 miles. We always say the x first and the y second. But slope is rise over run, so slope is the y change over the x change. So that's something to remember. We always flip in slope. We're flipping this. We're talking about rise on top and run on the bottom when we're used to saying x first and y second. That's something that confuses a lot of people. So we're going to go ahead. Like we said, we're going to pick the first and last point on that particular line. And what does that look like? Okay, point 1, point 2, x, y, our x for point 1 and our y for point 1, they're both 0. Our x for point 2, our x is 4 hours, and our y is 200 miles. So we put a 4 here, and we put a 200 here. You don't have to worry about units. Oh my goodness, isn't that fabulous? How do you calculate rise? You figure out how much the line went up from point 1 to point 2. So it went from 0 to 200. And the way you calculate that is you take the second number, the 200, and you subtract the first. And we say that what you're doing is y for point 2, or y2, minus y for point 1, or y1. So that is y2 minus y1. right? y2 minus y1. So y2 minus y1 equals 200 minus 0. And that's the same as 200. Yay! And we're dividing that by x2 minus x1. And our x2 here, it's 4 hours minus, and our x1 is 0 hours. So x2 minus x1 equals 4 minus 0, and that's 4. So rise over run equals our second y minus our first y, y2 minus y1 equals 200 minus 0 equals 200, divided by run, or across, our second x minus our first x, which is 4 minus 0, which is equal to 4. Our slope is 200 divided by 4, and last time I looked, that was 50. That's how you calculate slope. Yay! Okay. Why does a straight line segment like this, or this, or this, mean that speed is constant or unchanging? Here's why. If you calculate the slope on between any 2 points by using any 2 points on this line, you're going to get the same slope. Let's do it. Do it for a few of these. So I'm going to call this point 1, point 2, point 3, point 4, point 5. Okay? X, Y, okay? Our first X is 0. Our first Y is 0. Yeah? Our second X is 1. Our third X is 2, 3, 4. Okay? So our X's are 0, 1, 2, 3, and 4. And our Y's are 50, 100, 150, and 200. 0 first, of course, right? If you see? 0, 1, 2, 3, 4, 0, 50, 100, 150, and 200. Okay? Before we did 0.5 versus 0.1. Now let's do 0.5 versus 0.2. Okay? y2 minus y1 divided by x2 minus x1 equals, we're doing what? Did I say we'll do 0.5 versus 0.1? Okay, it's 4 minus 1. Oops, that's x, isn't it? Now I've made the mistake I always tell you not to make. Sorry, it's 200 minus 50 divided by 4 minus 1, which is 150 divided by 3, which is, oh, it's 50! Let's do 0.5 versus 0.3. 0.5 versus 0.3. y2 minus y1 over x2 minus x1 equals 200 minus 100 over 3 minus 1, which is 100 over 2, which is 50. 0.5 versus 0.4. y2 minus y1 over x2 minus x1 equals 200 minus 150 over over 4. Let's see, what am I doing? 5 minus 4? Yeah, over 4 minus 3, which the last time I looked was 50 over 1, which equals 50. Right? I made a mistake here, right? Didn't I? It's not 3 minus 1, right? It's 5. This isn't 3 minus 1. 200 minus 100 is 4 minus 2, isn't it? It's 4 minus 2. Same answer, right? And over here we have 4 minus 3. Okay? I guarantee you, if you do 0.4 to 0.2, let's do 0.4 to 0.2, okay? 0.4 to 0.2, y2 minus y1 over x2 minus x1 equals, let's see, 0.4 is 150 minus 50. And that's 3 minus 1. And that's 100 over 2, and that's 50. So, any 2 points on a given section of straight line will give you exactly the same slope. Okay? All right. If you don't believe me, do some more. So, oh, wait a minute. You just told me a line means slope is constant, but you didn't tell me a line means speed is constant. How do we make that connection, Mrs. Culver? Well, here's your answer. What's the definition of speed, folks? Yes, you all know. Speed is distance divided by time. What's y? Distance. What's time? What's x? Time. What do we keep calculating with these slopes? Change in distance divided by change in time. Distance covered on a particular segment of the line divided by time spent on a particular segment of that line. Distance over time, that's speed. That is the beauty of a distance versus time graph. The slope gives you speed. Yay! And since the slope is constant, the speed is constant. Now we have to talk a little bit about why average speed is average. And to do that, we're going to start looking at all 3 segments of our graph here. All right? We have a period of time here where we're going 50 miles an hour. Our slope is 50. We have a period of time here where we're going, what? Yes, 0 miles per hour. And you know that because you know that y, you know that this y is the same as this y. Okay, they're both 200. So if you subtract 200 from 200, you have 0. You've got 0 on the top of your slope calculation, right? Yeah. So speed is 0 here. And along here, we sped up. And we sped up so that the slope of this line is 75. We're going 75 miles an hour all along here. Every time we went over 1 hour, we went up 75 miles. So that's 75. From here to here is the rise change is 75, and the run change is only 1. Okay? So the slope of this segment of line, the blue segment, is 75. So 50 miles an hour, 0 miles an hour, 75 miles an hour. Let's look at why average is average. We're going to draw a pink line to do that. And we're going to run a straight line from 0 hour to 10 hour. Okay? Just going to run a straight line from that point to the other point. Well, we would do that in pink if my pink pen were working better on this page. We'll just go ahead and do it in red. Okay. So here we are from hour 0 to hour 10. Boom. There we are. Hour 0 to hour 10. We're going to find out something kind of interesting, aren't we? Let's calculate the slope of that line. So, let's look at, let's call this point 2, and we'll call this point 1. Okay? Point 2 and point 1. All right. At point 2, this is point 1, and you can do it this way if you like, if it makes your calculations easier. Okay, make ourselves a little chart for our 2 points. At point 1, distance was 0 and time was 0. At point 2, time was 10 and distance was 500. So distance is 500 and time is 10. We're on top of that, right? Okay. So, average speed equals total distance divided by total time equals the entire distance traveled from point 1 to point 2, which is y2 minus y1, and the entire time we traveled it from point 1 to point 2, which is x2 minus x1, and that equals 500 miles minus 0 miles divided by 10 hours minus 0 hours, which is 500 divided by 10, which is 50 miles per hour. And guess what? Miles per hour is what you're used to seeing, mph. But yeah, there it is. Okay, you see all that? Good. Why is that an average? Well, what do you do when you get an average? When you get an average, you add up all your different values, and then you divide that sum by the number of values you had, right? So let's do that with just the points we've defined along here, okay? So our speed along this, our speed along here was 50 miles an hour, okay? So let's look at it this way. Let's look at it as our speed. And we're going to look at hours 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? And we're going to look at our speeds. At hour 1, our speed, we know, was 50. And at hour 2, our speed was 50. And at hour 3, our speed was 50. And at hour 4, our speed was 50. At hour 5 and 6, our speed was 0. Right? At 7, 8, 9, and 10, our speed was 75, right? Okay? Let's look at all our speeds. 50, 100, 150, 200, 275, 350, 425, 500, right? Those are all our speeds. And how many of them did we have? We had 10 of them. 500 divided by 10 equals 50. It really is an average. And if you could, add up, if you did it every half an hour, you'd get the same thing. You'd just have 20 values, and 8 of them would equal 50, and 8 of them would equal 75, and 4 of them would equal 0, and you would add that up, and you would get 1,000, but you would have 20 different values, and you divide 1,000 by 20, and you'd get 50. Okay? All right. Now, one last thing that we need to go over, because it is still confusing to some of you, which is just fine. Okay, so speed equals distance divided by time. I love this thing that Ms. Wachnick did last year, okay, about how to figure out what goes in the box for long division, okay? Here's what she told you. She told you for long division, think of the fraction. Use your left hand for the numerator, for the top of the fraction, and your right hand for the denominator. Okay? So, distance divided by time. Now, the numerator, the top of the fraction, falls over to the right. That's what's in the box. Watch. Distance over time. There's your fraction. Distance is going to fall over. Distance falls over, and it is to the right now of time. When it fell down, it ended up to the right of time, and that's the way the box works. The one on the right is under the box. Right? Let's do that again, because I think I can do that better. Distance over time. Distance falls over so that you have time. And distance has fallen over to the right of time. Now you draw your box. Distance is in the box. Okay? I think that's everything I promised today. We're going to have to do, let's see, when we do acceleration, there's another thing that I want to cover, and that is units. All right? What are the correct units? That'll be the next video, I think, that I do with you. Okay? Remember, if you have any questions about this, just watch more of it. Thanks. Bye-bye.